Hi and welcome back. In this video, we're going to look at running multiple threads at once and sharing some state between them. Okay, so I've created a new file which I've called nonlockedthreads.py. But before we start writing some code, I just wanted to sort of tell you about something, and that is, what is an atomic operation? Atomic operations are very important when you're doing multi-threaded code. An atomic operation is one that cannot be interrupted in the middle of it. So you cannot interrupt an atomic operation halfway through it by changing to a new thread, okay? Whenever you're doing an atomic operation, you know that it's going to finish before you can unplug the thread from the core and put another one in. For example, a print statement cannot print only half the line and then be interrupted. Similarly, appending to a deck, or a DQ if you're like me and you like saying that, appending to a deck cannot be interrupted halfway through. If you start appending to a deck, you say, deck.append, you know that the thing will be appended to the deck before you remove the thread from the core. Okay, so atomic operations are very important when you have this shared state between threads. Okay, and we're going to look at an example of where we're going to have a function that's not atomic and why that poses a problem. Okay, so let's do that. I'm going to do, from threading import threads, I'm going to use good old threads instead of the thread pool executor just for this. I think it's going to be a bit easier to see what's going on. We're going to import time, and we're also going to import random because we're going to be randomizing some things. Then we're going to have a global variable in our file, which is going to be 0. Okay? And then we're going to have a function called increment counter. And what this is going to do is it's going to say global counter, access the global variable counter, do counter plus equal 1, and then print new counter value is counter. And then it's also going to print a few lines just so we can separate new counter values from one before the other. Now, from what we know about single-threaded code, if we do for x in range 10, and then we do increment counter, what do we think is going to happen? Hopefully you send, what I'd expect is that you'll start up here. X will be 0, it's going to run 10 times. The first time you're going to go into increment counter, you're going to access global counter, which is going to be 0. You're going to increase it by 1, so it's going to be 1. You're going to print out new counter value is 1. You're going to print out these lines. Then you're going to go back to the end of the function. You're going to repeat your loop. You're going to go in here again. Counter's going to be 1 now because it was increased before. Then you're going to increase it by 1, going up to 2. You're going to print new counter value is 2, and so forth for 3, 4, 5, 6, 7, 8, and so forth. So let's run this non-locked threads, which is not using threads at all. And you can see that that is indeed what happens. You get 1 all the way down to 10. So, good stuff. This is what we would expect. Now, what happens if we make a thread? We say t equals thread, and the target is increment counter. And then we're going to remove this increment counter, then we're going to do t.start. What do we think is going to happen when we run this? Let me tell you that we're not going to see any difference. Okay? We get 1, 2, 3, 4, 5, 6, 7, all the way up to 10. Okay, so what was the purpose of threads, and are they running at the same time? Using or writing multi-threaded code is dangerous because you may not see the problem straight away. The problem may only appear under some circumstances. And here is where time and random are going to come in. What we've got here is 10 times we're going to repeat this block of code. We're going to create a new thread. The target is going to be increment counter. And then we're going to start the thread. And then immediately we're going to move over to the next thread and we're going to start it. But this function is so quick to run that before we get to start the new thread, that function is already finished running. So essentially, this is sequential code. Essentially, it's single-threaded code. Because you create a new thread, you started. By the time you create a new thread, that one's already finished. So essentially, it's happening one after the other. What we're going to do is we're going to do time sleep random.random. Okay? We're going to put some time sleeps in here, essentially between each line. like that. This technique of adding random sleeps between statements when you're doing multi-threaded code is called fuzzying. It's very popular because it's going to let us see problems. Okay, let's run this file again. Ooh, that's not looking so good now. So as you can see, what happened here now is that all our threads were running at the same time. Because, one of them started, then it encountered this random sleep. By that time, another one had maybe started and encountered another random sleep. You've got a few of them starting, some of them are here, some of them are here. And what happens is you've got a couple of threads getting the counter value as 3 and increasing it by 1, both at the same time. Okay, so you've got 2 threads coming into the global counter. 2 threads are stopped here. The counter is 3. Then they both increment counter by 1 at the same time. So it ends up as 4. And then they both print out new counter value is 4. Okay? So multi-threaded code with shared state can be really tricky to get right. Because 2 threads can try to access the same thing at the same time. And that's fine. You can access the same thing at the same time. But you may not end up with what you'd expect. Particularly if all the threads are changing something in this variable at the same time. And you may not see that unless you do this fuzzying technique or other techniques. So what we've got here are all our threads running. They're messed up essentially. We cannot proceed with this. And if you remove the fuzzying, it will work until your computer is running slowly, or you've got a bunch of things running at the same time in your computer, and these threads are jumping in and out of course very quickly. Then you may start encountering problems like this one. So, you must be careful when you write multi-threaded code. You must be very careful. Especially if your threads, or really only if your threads are modifying shared state. Here, the variable is the shared state. These threads have that variable shared amongst them. Dangerous stuff, okay? This code, by the way, and also the code that follows, is taken from a talk that one of the Python developers, the creators of the Python language, made. I'm going to link you to this talk at the end of this section. So it's really good. I just want to guide you through it first, in my words, just to help you understand it, and then you can go and watch their talk later on. Okay? If we wanted to make sure the operations happen sequentially, like we want to do new counter value is 1, then new counter value is 2, then 3, then we would have to do something much more complicated. But again, if you want to make sure the operations happen sequentially, don't use threads. That's the first thing. If you want to make sure the operations happen sequentially, but you want to use threads, then you have to set up a queuing system where each thread can perform the operation of incrementing the counter, but they happen one by one. And so it's going to be more complicated code. Let's go over it in the very next video, how you may do queuing with the threads so that the operations happen sequentially. I'll see you in the next video.